currently pursuing BTech in Artificial Intelligence and Data Science in the Department of Data Science and Cybersecurity in Karnal University. In this video, I will demonstrate EDA using Python for a synthetic prostate cancer is dataset. This is the part of my data science lab book 3. I will take you through all the steps of EDA, including data cleaning, handling missing values, detecting and removing the outliers, analyzing the central tendency and variability, and visualizing the relationship through plots and heat maps. Before move on to the questions, I would like to say what is exploratory data analysis. It is the process of analyzing dataset to summarize main characteristics, detect patterns, and find insights using the statistical and graphical methods before applying machine learning or modeling. First question, remove the irrelevant column. In exploratory data analysis or machine learning, some features don't add value to production. Keeping irrelevant data can cause add noise, increase computation data, reduce model accuracy. Let us run this code so you can understand better. So here, dataset before removing irrelevant column, dataset after removing irrelevant column. Here I am mentioning that irrelevant column is sleeping house. Next question, remove the duplicate rows and outliers. Duplicates can bias result efficiency, such as rows, waste memory, and slow down the analyzers. Clean data so it can give better insights. Your result will be more trustworthy when every record is unique. See here, there is no duplicate rows before removing and after removing. Renaming the column. Why we want to renaming the column in a data set? Renaming column in a data set makes them clear, consistent, and professional for analyzing and presenting. Consistent column names avoid errors in the code. See here, updated column names. Here I am updated BMI into body mass index and risk level into project risk level. In place. Okay, right. Next question. Here we are dropping the missing values and observe. Dropping missing values ensures the dataset has only complete records, which makes analysis more reliable. But it reduces the dataset size. Instead of dropping, you can fill in the missing values with mean, median mode, or even predictive models. We'll run this code. See here, there is no missing values before dropping and after dropping. See, shape before dropping is 1003. Shape after dropping, it reduces into 605 in 30. Next, we want to show the box plot visualization and detect the outliers. A box plot is used to visualize the data distribution and detect outliers. Outliers are values that fall outside the normal range and defined using the IQR method. Box plots are great for univariate outlier detection, but for multi-dimensional data. Other methods like z-score or dp-scan are used. I will this code. See box plot of age. Number of outliers in each. There is no outliers in each. Next, calculate the central tendency measures. Central tendency, it describes the typical value of a data set. I would like to tell about what is mean. Mean is this arithmetic average and median is a middle value. Mode is the most frequent value. Mean is sensitive to outliers on extreme level can rise or lower it. Median is more robust when data is skewed. Mode is useful for categorical or repeated values like risk level is equal to high, medium, low. I would like to run this code. See here. It shows the column ID for mean, median, mode, and age, mean, median. It shows the for each one ID, age, BMI, and sleep loss. For each one, it is showing the mean, median, and mode. Next question. Calculate the variability measures. What is the variability measures? Range, variance, and standard deviations. What is range? Difference between the highest and lowest value. Variance, how far values deviate from the mean. Standard deviation, typical deviation from the mean. I like to run this code so you can understand better. See here, it shows the for each one, it shows the range, variance, standard deviation for ID, age, BMI, and sleeping hours. Next question. Calculate the IQR using quantile. It measures the spread of the middle 50% of data and it is used for detecting the outliers. IQR is most troublesome range because extreme values don't affect it. See here, age it shows the 25th percentile and 75th percentile. Next question, remove the outliers using IQR. Outliers are removing using the IQR method, keeping only rows where values lie within this range from Q1 and Q3. Here there is mentioning 1.5 into IQR. Removing outliers improves data quality and model performance. Some outliers may be important insights, so always analyze before removing. See here, see here, original number of rows that is 1000. Number of rows after outliers removal 994. Number of rows removed outliers 6. So here is the clean data from height. Next question. Plot the heat map using the correlation. The correlation heat map visually shows how numeric variables are related to each other. Correlation does not imply causation. It only shows a linear relationship. Heat maps are very useful in features selection for machine learning. See, this is the correlation heat map of numeric variables. So here we are calculating age, BMI, sleeping hours. Next question. Here we want to calculate the z-score. What is z-score? It's standardized numerical data to compare different columns on the same scale and detect outliers. Outliers detection. So z-score must be greater than 0 or less than -3 is often considered an extreme value. What is standardization? Z-score are used before machine learning algorithms that are sensitive to scale like kernel SVM. So is also calculated and saved to is equal progress.c. Okay, this is saved into this CSV file. So here it shows first row of the z-score data frame. Next question. Remove the outliers using z-score. Removing outliers using z-score eliminates rows where numeric values are extremely far from the mean. Z-score method is scalar independent, unlike IQR, which depends on percentile. Here it is mentioning z-score is independent and IQR is dependent on percentile. So I would like to run this code. So here you see the z-score, original number of rows after z-score outliers removal, and the number of rows removed. I hope this demonstration helps you understand the EDA process tree. Thank you for this. Thank you for watching this demonstration. This is by Alpha. My register number is URK24AI1035.